Creating a fantasy world offers a sense of liberation. It's the same adventurous feeling a child has when they're completely lost in a game of make-believe in a backyard garden, a space where you can stretch your imagination as far as you want. But when you remove every defined limit, you create a hidden burden for the audience. Without a familiar structure to hold onto, the brain is forced to constantly interrogate the reality of the setting, trying to reconcile the impossible with the logical. After hours of this constant mental friction, like watching a 3-hour epic where nothing follows a recognizable rule, the brain can become physically overwhelmed. This mental exhaustion is why many people feel a sense of dizziness or disorientation when the credits roll and they have to suddenly adjust back to the real world. To prevent that fatigue, we're going to build a foundational fantasy map that strikes a balance. We'll use real-world science to anchor your aesthetic choices, giving the reader's brain a rest. To follow along, you'll just need a drawn tablet or a simple piece of paper and a pencil. By establishing a firm structural foundation based on reality, you create a space where your imagination can safely run wild without confusing your audience. We start with pure imagination. Go ahead and begin lightly sketching the abstract, jagged outlines of your continents and islands. To ground these shapes, we'll apply our first scientific rule, the movement of tectonic plates. This diagram illustrates how to map these invisible forces. Drawing intersecting lines across the landmass marks where the planet's crust fractures. Now place mountain ranges specifically along these lines. These represent where plates collide, pushing the Earth upward. Avoid the common mistake of placing random blobs of mountains in the center of a landmass. Without a geological reason for them to be there, they feel like ornaments rather than part of a living world. Placed correctly, mountains stop being decorations and become physical scars of the planet's internal history. Next, we look to the atmosphere. Establish an equator on your map to determine which way the prevailing winds are blowing. This leads to the rain shadow effect, the process where high mountain ranges physically block weather systems from moving across the continent. As wind hits your mountains, moisture is forced out. Color the windward side green to represent heavy rainfall and lush forests. By the time air passes the peaks, it's dry. Color the opposite side brown to represent an arid desert starved of moisture. These distinct biomes, rainforests bordering deserts, feel believable because they are the logical result of your geography interacting with the wind. We move now to hydrology. On any planet, water flow is strictly governed by gravity. Carve rivers starting from the highest mountain peaks. They must always flow downward toward the sea. Pay attention to this diagram. A common error is showing rivers splitting apart as they travel. In reality, they only converge, merging smaller streams into larger ones as they find the lowest path. Now that physics are established, re-inject the make-believe. Draw impossible, magical landmarks, like this glowing crater, directly into your scientifically accurate forest. Bizarre elements like these feel plausible to the reader because they sit on top of a strictly logical geographical foundation. Take a moment to look at your fully drafted map. When you compare this to a map where mountains and rivers are placed randomly, the difference in aesthetic appeal is clear. This underlying structure is what keeps the reader from questioning the world, allowing them to focus entirely on the story you're telling. The payoff is a world that can sustain a long narrative without requiring your audience to spend hours recovering from the mental strain of illogical geography. If you're interested in more world-building techniques rooted in science, like and subscribe. Ultimately, your imagination is at its most effective when it is framed by the laws of physics.